Okay, I found a room. Hey everyone who is joining this live stream. Sorry that I'm late. Was not intentional. Could not find a room, so I was running around frantically trying to find one. But it's all good. We're here now. We're here now, and that's the main thing. Thank you everyone for joining. And again, sorry for the delay. I know it sucks, but we should all be cooking with gas. I'm in my strange person walking past. Fine. People always look at me like, what is this guy doing in here? So this is our first A Level stream, and what I wanted to do is basically just go over some, like I call it a Hyperblitz. It's just a bunch of different chemistry, a bunch of based on, but I had to look at the specifications, and OCR and AQA are really similar, so it should be good for either of those examples. And hell yes, there is a gong. Bam! If you are new to this stream, we hit a gong a lot. It's really fun, I promise. And if you get the answers right, you get a gong. So like you get a gong, and you get a gong, and you get a gong. It's like it's a riot. So it's going to be 15 minutes. It's going to be fast. It's going to be furious. Like I hope you're ready. Like while I was waiting, I had an espresso, so I'm like, boom, 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 I'm ready to go. When I get my screen sorted, remember there are some key tips to remember for any kind of chemistry exam that you're taking. One is you always want to make sure that for calculation questions, write out any formula you're using, because a lot of the times you get marks for them. Show you're working, and read the question properly, all that stuff. Now, okay, so I've got the Hyperblitz ready. Any questions you've got, shout out in the chat, and I will shout out to Genius456. There you go, you're welcome. And every time you get a question right, we'll get a gong. This is the first A-level one. So we'll see how it goes. But I thought it would be good to do something for the people who are using Seneca for A-levels, because a lot of our stuff, it's like, you know, we're varying it. You're welcome. You're welcome. Okay, so you will lose me for a second, but you will see me again really soon. And like, I'm just going to run through this really quickly because people might be watching this after, but this is just a run through of like topics and like tricky questions I thought would be good to go over. So what are the type of intermolecular attractions occurring when you dissolve formaldehyde in water? So this is an intermolecular forces question. So I'll give like a cute little pause to give you guys a chance to answer, but we've got to move through quite quickly. So if I don't give you enough time, I'm really sorry. So again, this is when you think about intermolecular forces, you want to be thinking about, is it going to be hydrogen bonding? Is it going to be van der Waals forces? Is it going to be dipole-dipole interactions? Now formaldehyde, it's formaldehyde. You should be familiar with that functional group. We've got that carbonyl O, and we've also got the CHO group. So we've got an O and an H. So we're going to have some nice hydrogen bonding going on in there. Oh God, I dropped the gong thing. Next, we want to investigate the pH curve. We've got a weak base and a strong acid. To do this, the student decided to add sulfuric acid to 25 centimeters cubed of ammonia, whilst constantly monitoring the pH using a pH meter. Sounds great. So what do we need to do? So we need to write the equation with the correct state symbols. Now it's a titration. So like straight away, what I'm going to do is I can tell that we're not going to have solid ammonia. It's going to be aqueous. So I know it can't be the top one. Then when I'm balancing equations, I like to do it one element at a time. Otherwise, honey feels a bit overwhelmed. So if we look like straight off the bat, I can see, look, we've got 2N here, and then we've got 3 on that side. So it's got to be the middle one. So always take your time to balance equations, because they're easy marks in the exam. So next we have a titration graph. So acid and bases are an important thing to know all about. Love it, love it. And then often they're going to ask you to pick an indicator. Now, my tip for picking an indicator is you want to be looking for the equivalence point, and that's when that is always this section in the graph, the straight line section. That's when we have the right amount of titrant added to the solute to have neutralization and pH change. So then you look at the pH range in which the equivalence point occurs, and that's how you can pick your indicator. So you can see here, the equivalence point is from like 8 to 2 is kind of the pH range. So that fits better with methyl orange. Like if we look at phenolphthalein, which is so hard to say, it's like pH 8.2 to 10 is the pH range. So that's the pH range it changes color. And if we look at 8.2 to 10, like we're up here, we're in like a special part of the titration curve, which I'm not going to say because we're going to be labeling that later. So always look for the equivalence point when you are picking your indicator. Another equation question. I'm so good to you. Great question, Jacob. Yes, you won't be expected to just remember the pH ranges of the indicators. They will give them to you, but these are the two most common ones. So methyl orange is like 3 to 4 and phenolphthalein is like 8.3 to 10. Okay, so next we want the equilibrium reaction between water and ammonia. Now, when ammonia forms an ion, remember it's NH4 plus. So again, just by looking at it, I know it's got to be that top one, and that's a dative covalent bond. That's what's special about the NH4 plus ion. It forms a dative covalent bond because both of those electrons come from the nitrogen atom. Boom. Excited. So we've got a nice cute little endothermic reaction, and the order reaction decreases from reactants to products. So what does that mean? So now we're getting into some free energy Gibbs stuff. Love it. So if we know it's endothermic, the equation for Gibbs free energy, delta G equals delta H minus T delta S. Now if it's endothermic, that means delta H is positive. Now for a reaction to be feasible, it has to have a negative delta G. So that means our T delta S has got to be a big number. So the reaction is only going to be feasible when the temperature is high. We know delta S is positive because we are told that the order of the reaction decreases from reactants to products. Okay, assigning charge. Let's do this. I'm ready. Are you ready to assign some charge? I am so excited. I'm going to go on. First gong of the lesson, and first time people are gonna be like, what is this guy doing again? Key things to remember with these, we want the charge of the ion 3 complex in this. So ion 3, when we have those Roman numerals, bam, we know that the charge is going to be +3 for iron. So iron is +3. OH is always minus, so we've got Fe 3 plus OH. So we're at a +1. But NO3 has a minus charge. So Fe3 plus OH minus. So can you give me some tips? I am seriously just exam tips for the exam in general, or for what? Give me some exam tips on like how to spend the evening revising. Just let me know. So with this one, a quick way to do this, we know NO3 is minus, so we know that this complex has to be +1 because overall we have a neutral charge. Okay. For K, for the rate equation, easy way to remember it. If it's x squared, it's going to be mol to the -1, dn3s to the -1. If it's x squared y, then it's going to be this bad boy. And if it's just first order, then it's just per second. So if we're looking for revising tips for the night before the exam, I would say you want to be going over high yield topics. High yield topics, so stuff like make sure you know all your equations, so go over like moles, ideal gas equation, concentration, enthalpy, PV equals nRT is the ideal gas law. You want to go over Q equals MC delta T. Equations are good, lots of calculations in A-level chemistry. We're going through a bunch of stuff now, so that will also help. Try and work in like 25-minute intervals, and then take a 5-minute break. It's still important to give your brain awake. And do you know what? This exam is going to be over real soon. You're at the last hurdle now. It's the night before the first exam, so just like forget about the past and just focus on the moment and be like, do you know what? It's okay. I'm going to do what I can tonight, and just do it in like 25 minutes at a time. Take a 5-minute break. So it doesn't feel too overwhelming, and make sure you get a good night's sleep. And just know it's going to be over soon. And yes, exams are important, but there is so much more to life than exams. So revise, work your hardest that you can tonight, get a good night's sleep, and just get that exam over with. Like, you're going to be fine, and you're going to feel so good when it's over. And you're very welcome. So we've got to go. I'm doing an English language live stream after this, which I'm excited about. So if you want to do GCSE English language, check it out. There'll be a gong. It'll be fun. So we're told that this reaction is feasible above 850 degrees Celsius. Now, when a reaction is feasible, that means it occurs spontaneously. Now, if we're at 600 degrees Celsius, the first thing we know is that we know that delta G has got to be positive because the reaction is no longer feasible. So we can get rid of those top two answers. Now, we are told that we know that delta H has got to be, delta H is going to be positive because it's a thermal decomposition reaction. So we know that it's going to be endothermic. And because this reaction is feasible, we know this reaction is feasible at 850 degrees Celsius. We know that delta S, T delta has got to be positive. Otherwise, if delta S was negative, this reaction would never be feasible because delta G would not be above, would not get below 0. I hope this is making sense. And glad you're going to be there, Adam. It's going to be fun. So which of these requires the greatest input of energy? So here we're going from an ionic lattice and we're making those gaseous ions. So my top trick for this is there's two things you need to look at. Firstly, charge, secondly, ionic radius. So first of all, we can see that it's gonna be between Ca2 plus O2 minus and Mg2 plus and O2 minus because they have the greatest charge. So it's going to require more energy to break up the bonds holding together that lattice. Now, Mg is above Ca in the periodic table. So Mg has a smaller ionic radius. What does that mean? We can pack those ions in closer together so there are stronger attractions. So MgO is the one we're looking for. Now, what we want to do the oxidation state of iron. So my tip for when you're doing oxidation states of complex ions, always start with what you know. We know that OH is always going to be a minus. H2O is neutral, so we know OH minus, so that's -1, -1. Br, that's a nice little halogen, group 7, so we know that's also got to be -1. So we know that overall iron has got to be, it's a neutral complex, so iron has to be +3 because we've got OH minus, and a Br minus, okay? Tip for buffer questions, I would say always just take it really slow, show all of your working, draw out those nice ice tables if necessary for the initial concentration, change in concentration, the end concentration. Even if you're not entirely sure how to do the whole question, still write out something, still write out some kind of equation, just because that can get you a mark. Okay, this is a good tip. Which of the following will change Kp? Kp is only affected by temperature. Kp, equilibrium constant for a gas, only affected by temperature. Remember that. Okay, hydrogen being reduced. The only time hydrogen is reduced is when it's reacting with a metal, because metals always have to be positive. So that's my little tip for that one. Okay, EMF question. So this is how we write the notation for a cell. And it always goes anode and then cathode. It's like the alphabet A and then C. And when we're doing, the first thing you want to determine is, okay, where's everything going? Now, if we're going from, at the cathode is going to be the copper, so that's where reduction occurs. Reduction is the gain of electrons. So electrons do flow from the zinc anode to the copper electrode. Bam. So at the anode, we have oxidation, so it's not reduced. Zinc electrode has positive polarity. Metallic copper will be oxidized by the zinc ions. Nope, copper is going to be reduced because it is the anode. So the titration of a strong acid gives the following titration curve. Where is the buffering point? That is going to be B. That is just before the equivalence point. Cool. Okay, we did it. That was a very quick hyperblitz of some key topics that are going to be on paper 1 tomorrow. Tips for exam members: show as much working as you can. Write out every equation you use, especially in those moles ones. And I would spend your evening just reading over some of the equation questions, looking over some past papers you've maybe done before, and reading the mark scheme. Reading mark schemes and past papers is super helpful. And I need to go get a glass of water before the next live stream in 3 minutes, so I've got to run. But thank you so much for joining our first A-level hyper stream. If this was useful and you want to see more of these, let us know. We'll be doing a bunch more hyper streams over this week, so subscribe to our channel to keep updated. And thank you very much for joining. And hopefully I will see you guys soon. Best of luck for your exam tomorrow, and you're going to do great. Good luck, everybody.